Vaccination, the administration of a vaccine, the antigenic material from pathogens, prepares the body for future infections by a specific pathogen. When a vaccine is first administered, an antigen-presenting immune cell, or APC, such as a dendritic cell, engulfs the antigen from the vaccine, degrades it, and displays pieces of the antigen on its surface. APCs then activate T helper cells, or Th for short, that trigger cytotoxic T lymphocytes, or CTLs, also known as killer T cells, and B cells. Once activated, CTLs are able to detect infected cells, bind to the cells, and release chemicals that kill the cells, along with harbored pathogens. Post-activation by Th, B cells divide into plasma and memory B cells. The plasma cells make antibodies that bind to vaccine-introduced antigens to destroy and eliminate them from the body. After the vaccine-induced mock infection is cleared, some T cells get converted into memory cells that can readily divide and grow whenever re-exposure occurs to the same pathogen or its antigens in the future. The memory cells and antibodies generated via vaccines against a specific pathogen remain in the body for months or years at a time, depending on the vaccine. When an individual gets infected by the same pathogen or antigen that they were vaccinated against, the memory cells will recognize the antigen and can divide rapidly to produce a quicker immune response.